question types I predict you're going to run into on the August SAT, starting with useless graphs in the English section. And I'm talking about these questions right here, quantitative command of evidence questions. And real quick, if you want to do these questions with me, just click the link in the description. Now, I'm not saying that all the graphs are useless, but the majority of these you could actually solve without ever looking at the graphic. So let's go ahead and ignore this one. And what you're going to want to do is focus on supporting whatever came before the blank space. So if I start with my last sentence even, we have the greatest contributors to the global increase have been countries like Canada. So I know that I'm looking to support a global increase, and I just need to know what that increase is in. Based on the answer choices, I already know that it's the bald and bearded population, but if I needed to, I could cherry pick the passage just to clarify that one point. So let's just go ahead and support that idea. A, whose bald and bearded population was 20% in 1995. I already know that that's not going to work because we only have 1 year. Showing what a population was in a single year does not show growth, so A doesn't work. B, whose bald and bearded population grew at the same rate as Norway between these years. So here we have a couple years, but it's saying grew at the same rate as Norway. I'm not looking to compare two countries. I'm looking to just simply show growth. So B is also not going to work. C, whose bald and bearded men reached 50% in 2025, around 35% lower than that of Australia. Same issue, we're comparing to another country. We're also saying that it's lower than another country, but we're supposed to be one of the, quote-unquote greatest contributors. So that's not going to work. And then, D, whose population went from around 10% bald and bearded in 1975 to more than 40% in 2025. That shows growth, right? So D is going to be our answer. Up next, we've got structure questions. And these questions are actually really easy if you know how to approach them. Basically, we're just looking to identify the different sections of the text, and we can keep it pretty vague. So, for example, if I'm reading through this one, I would say, many bird species migrate thousands of miles each year. So right off the bat, I'm thinking something like, part 1, introduce a thing that happens with birds. Then we have how they've studied it, and they talk about a theory, and then they give us some evidence about that theory, and then some other evidence. And I'm just kind of glancing over this because it seems like all of this goes together. And I would say maybe for part 2, it gives examples or explains how this thing happens. So going through my answer choices to eliminate the text, and I like to start with my first one actually. So remember, the first one was birds do this thing. So A, the text describes a general phenomenon. I'm just kind of glancing over this because it seems like all of this goes together. And I would say maybe for part 2, it gives examples or explains how this thing happens. So going through my answer choices to eliminate the text, and I like to start with my first one actually. So remember, the first one was birds do this thing. So A, the text describes a general phenomenon. Birds doing the thing, that is a general phenomenon, so I would keep it. B, the text presents conflicting theories. No, it does not. C, the text discusses several notable researchers. No, it does not. This might be a distractor answer because we do get a couple of different pieces of research, but it doesn't talk about different researchers, and order matters. That's not the first thing that we get, so C doesn't work. The text identifies a problem with migration patterns. It's not a problem, it's just a thing that's happening. So without even reading the second half of my answers, I already know it's A, but then it provides specific evidence to explain how it occurs. That goes along with my other prediction, right? Up next, comma splices. And these are probably the most common type of error that shows up in the answer choices for boundaries questions. And what a comma splice is when a comma is trying to act like a period. That is to say, it's trying to separate two independent clauses, which it is not allowed to do. So, for example, on this question, and I sort of gave away the answer, or at least I gave away one of the wrong answers already. If we look at B, there's a comma here, right? So starting from the beginning, we've got, on windy nights, unsecured patio furniture can slide across decks or sidewalks, creating hazards and damaging surfaces. Boom, that's the end of an independent clause, right? Placing heavy sandbags or using anchoring straps, we could ignore the non-essential information here. can help prevent these problems. That's also an independent clause. So what we need is a period or a semicolon, because both of those things are allowed to separate independent clauses. This would be a comma splice because, again, we can't use a comma to separate two independent clauses. So we would eliminate choice B. And I know what you might be thinking, what the heck, man? We have a period and we have a semicolon. But notice the word by gets added here. Believe it or not, we could also use a dash to separate two independent clauses. But again, by is rooting this and making it so it is no longer independent. Because then it would read, by placing heavy sandbags or using anchoring straps can help prevent these problems. We've got an issue, right? So A and D aren't going to work, and it's going to have to be choice C, just the period. My next prediction is going to be subject-verb agreement questions. And I would argue that these questions, at least up until this point, have been the easiest questions on the SAT because we don't even have to read the passage. All we have to do is use the odd verb out trick. The odd verb out trick is which of these is singular while the other three are plural, or vice versa. So we can simply take they and we can take she, and we can connect these to our answer choices, right? What would we say? She was, she has been, she is, but we would say they were. So were is the odd verb out, and were has to be our answer. And if you're not satisfied with that, we can check real quick, right? We have the increasingly erratic behavior and the growing tension. Plural subject, were. And my final English prediction is colons. All right, and let's take this question for example. And even though you usually only need to read the sentence with the underlined portion for boundaries questions, I'm going to go ahead and read this whole thing just because I think it's a beautiful story. A ship captain is told an enemy ship is approaching. He orders his first mate to bring him his red shirt. So if he's wounded, the crew won't see him bleed and lose morale. After defeating the enemy, he's told an entire enemy fleet is approaching. The captain's order to his first mate says everything. Bring me my brown pants. So we're dealing with quotes, and a lot of you might be thinking, well, it's choice B, right? We use commas to introduce quotes. But that is not always the case. We do not have an independent clause. We would simply say something like, Bob says, comma, I don't like fish. But in this case, we actually have a full independent clause. The captain's order to his first mate says everything. So a comma is actually not going to work because, again, that would be a comma splice, right? We could use a period, right? But the issue with choice D is we don't have our first quotation mark, so that's not going to work. So D is out. So then we know that B is also not going to work because it's a comma splice, and then A is not going to work because we need some sort of punctuation. So we're left with C, which is a colon. And a lot of students think that colons are just used to introduce lists, but that's not all they do. In this case, I would say the colon is resolving a cliffhanger, which is another thing that colons are allowed to do. And of course, I do break down everything that colons do in detail in my punctuation and grammar course. And speaking of which, those strategies we just went over make up just a tiny sliver of what I offer in my full English bundle. The 3 courses included give you every strategy that you need to get a perfect 800 in the English section. And they also include access to over 500 original practice questions. If you're serious about getting your highest possible score in the English section, I'll go ahead and leave you a discount in the description of this video. All right, moving on to math, we've got perpendicular lines. And the thing you need to know about perpendicular lines is that they form a right angle, and because of this, their slopes are the opposite reciprocals of each other. So for example, if I had something like y equals, I don't know, just 3x, the opposite, yellow is a terrible choice, y equals 3x, the opposite of 3 would be negative 3. So when I say opposite, I mean, negative turns positive, positive turns negative. And then the reciprocal is when you have a fraction, so 3 over 1, and you flip it, so it would be 1 over 3. So the opposite reciprocal would be negative 1 over 3. And there's a beautiful graph as well. So you can see that these guys indeed form, right angles with each other. Anyway, on to this question. So we know that line J is perpendicular to line K. So the first thing that I would do is probably just put it in slope-intercept form, because for me that's visually easier to see. So I'd move that x over, we get y equals negative x plus 4. So we already know that the slope of line J is going to be just x, because, this is basically negative 1x, and 1 over 1, the reciprocal is still 1 over 1, but then it just flips to become positive, right? And then it tells us that the y-intercept is 0, negative 6. So actually, I know the full equation for this other line. It's going to be y equals x minus 6, because this is the y-intercept, and in slope-intercept form, this is the y-intercept, right? Now, I don't have that as an option, but I just have to move stuff around, right? Because this is all in standard form. So basically, if I moved my y over to the right side and I moved my 6 over to the left side, I would subtract y, so we would have x minus y, and then on the left side, I would have to add that 6 to move it to the left side, so then x minus y equals positive 6. That's going to be choice C here. That's going to be our answer. And speaking of perpendicular lines, my next prediction is tangent to a circle questions. All you need to know about a line that is tangent to a circle is that it is perpendicular with that circle's radius. So, when they tell me that line M is tangent to a circle at point 7, negative 1, and that the circle has a center at the origin, we can imagine we've got our circle here. It's right at the origin, right? So this is 0, 0. And then whatever this point is, 7, negative 1, I don't know, let's say it's over here. We can see the radius right here. And we know that the line is tangent to it, so it forms that 90-degree angle, right? So visually, this is going to be not great, but I'll do my best. It's really bad. Visually, it's something like this, right? We have a straight line. We're forming a 90-degree angle. So all we have to do is figure out what's the slope of our radius here that we drew, and then the opposite reciprocal will be the slope of line M. And since we have 2 points, we can just use the slope formula, or if you're really lazy, you can just plug it into Desmos as a table, and I'll show you that because I think it's a nifty little trick, especially if you have bigger numbers or something. This one's obviously pretty straightforward, because y1 minus y2, x1 minus x2, they're all 0, right? So we know that our slope is negative 1 over 7, but I could also grab Desmos and literally just put it in as a table. Type the word table, x1, 0, y1, 0, x1, 7, y1, negative 1. Click this little button here, boom. They tell us everything, right? We know that the slope is going to be this decimal here, which isn't quite as helpful, but if we typed it out and matched it with our answer choices, it's basically going to be negative 1 over 7, right? If I go to line 2, negative 1 over 7, that's the decimal that we're looking at. So, and remember, this is the slope of the radius that we drew, so the opposite reciprocal would be positive 7 over 1, also known as 7. My next prediction, forms of quadratics questions. And knowing forms of quadratics is going to be useful in getting the correct answers on certain questions, but it's also going to just make things go faster on other questions. So for this one, for example, you could easily plug this into Desmos and get your answer. We just grab our calculator, plug it in, and then look at our x-intercepts, and we know the other one is 6, 0, right? So our answer is 6. And that was fast. But if you are aware that we are in vertex form here, and you know because we're in vertex form that the vertex is 3, negative 18, and we know that the first x-intercept is at 0, 0, the x-coordinate of the vertex is going to be the midpoint of the two x-intercepts. So if we start from 0 and go to 3, we just have to add another 3, and then our answer is 6. So saves you maybe 2 seconds. But a cool little trick if you ever run into another one of these where you have 0, 0 as one of the x-intercepts. Next up, we've got tricky unit conversion. And I did say that this is tricky, so go ahead and pause the video and try this one on your own first. And let's see how many of you choose the trick answer. So it says a rectangular nature reserve has an area of this number square yards, which is the closest to the area in square miles of this reserve. So we know we're converting units because we have yards turning into miles, and they give us the conversion, which is nice. Now, the reason this is tricky is a lot of students are going to simply use this conversion, right? If we want to turn these yards into miles, according to the conversion here, we really just have to divide by 1,760, right? And if we do that, we get 4,066.18, choice D. But choice D is not the answer. And here's the reason. It's not talking about yards and miles, it's talking about square yards and square miles, which means this conversion isn't going to work straight up. Instead, we have to square our yards. So instead of 1760, it would be 1760 squared. And then we get the correct answer, which is 2.31. Boom. And my last prediction for the math section is going to be constants matching questions. And these kinds of questions are kind of scary looking, but there's a really cool trick that we can use to solve them, which is the matching trick. So if we have equivalent expressions like this, and we're dealing with multiple constants, we just need to isolate like terms. And what's even better is we don't even need to isolate all of the like terms, just the ones that we're looking for. So here it says we're looking for the value of a, b. So I am going to start to FOIL out the left side, but I'm not going to FOIL out the whole thing. I only care about where ab shows up. And the only time ab shows up is when ax gets multiplied by negative bx, which would turn into negative abx squared. So we have negative abx squared, and the cool thing about equations is all of the like terms are going to be equal to each other. So this, combined with all the x squareds, is going to be equal to all the x squareds on the right side. And on the right side, we have negative 13x squared. I don't care about this. I don't care about this stuff, because we're just focusing on whatever ab is attached to, and it happens to be attached to x squared. Now, this is not quite finished because we still have to account for any remaining x squareds on the left side. And when we multiply 3 by 5x squared, we would get 15x squared. So we would add 15x squared as well. And then from here, it's pretty straightforward. We can get rid of x squared because we divide the whole equation by x squared. We subtract 15 to get it over on the right side. And then we have negative ab equals negative 28. So positive ab would equal positive 28. So our answer is choice C. Now, of course, these constants matching questions are not the only type of constant question on the SAT. This video right here is going to teach you how to deal with every single type of constant question that you'll encounter. You guys have made it clear that reading comprehension is one of your biggest challenges. So in this video, I've compiled all of my strategies for reading questions on the SAT. Let me go ahead and demonstrate this APE method for you using an easy question. So the A is going to be analyze, and we're simply going to analyze our passage or our sentences looking for context clues. That's kind of vague, so let me show you what I mean. The invention in 1958 of the integrated circuit or microchip radically altered the semiconductor industry. In fact, so right here, I'm going to pause and I'm going to note what kind of transition this is. And if you've downloaded my free transitions worksheet, you know that in fact is going to be under the category of an emphasizer or an intensifier. So whatever comes after this needs to intensify the fact that this microchip radically altered the semiconductor industry. So that's one of the ways that you can look for context